We will briefly review measurement-informed inventory as outlined in this diagram. Let's begin with step A, inventory matching. In this step, the analyst mainly uses prototypical site models to replicate inventory reports. While Maze outputs are stochastic, annualized results can be directly compared to annual reports, assuring that the initial Maze model represents inventory reporting. Maze replication of inventory reports often identifies issues with inventory reporting, which is useful to operators who can update their inventory process, and useful to program operations who can tune reports requirements or instructions for reporting. In the emission survey and classification step, step B, comparing top-down survey data to operator records and other data typically identifies maintenance events that were detected by the survey. Since most survey methods cannot accurately measure highly transient maintenance emissions, maintenance is modeled in this step, step C, separately from both surveys and Maze simulations. These emissions are characterized by lists of known maintenance activities kept by operators, coupled with estimates of emissions from each event. The remaining non-maintenance detections are classified by cause, identifying some survey detections as already in the Maze model and others as additional to the Maze model. We will move to step D, measurement-informed inventory. These data are integrated into the Maze model. Emitters in the model are compared to the inventory reports and Maze model outputs to identify differences in the frequency and emission rates by emitter type. These data can be used to adjust Maze simulation parameters. Emitters that are not in the Maze model can be characterized by frequency and emission rate observed in the survey or surveys and added to the Maze model. At the end of step D, the Maze model contains both a full representation of operators' inventory reports and a full representation of any additional emitters identified by surveys with no overlap or duplication. The results is a robust measurement-informed inventory. There are additional details for this model on the METEC Measurement-Informed Inventory webpage and in the research paper titled Using Measurement-Informed Inventory to Assess Emission in the Denver-Julesburg Basin.